say exact values. So you learned some of this in year 10, so we're going to revise this today. So have a look at the triangle on your right. You will see it's an isosceles triangle because it has got two sides equal. We're going to find the exact length of AB using Pythagoras and label it on the diagram. So to find AB, you go AB equal to square root of 1 square plus 1 square, isn't it, using Pythagoras? That will be root 2. So the hypotenuse is root 2. So write that down. Once we do that, we're going to find some angles using. So we have to find angle BAC and ABC. Alright, so you have to find these two angles. Right, so because it's an isosceles triangle, what do we know about angle A and B? They're equal because it's isosceles, isn't it? So we can say angle A equal to angle B because it's isosceles. Isosceles. Alright, so once we know that equal, this is still not enough to work out the missing value. We have to use another rule. They're equal, but because we know angle sum of a triangle is 180, we can work out the value of A and B. So maybe we can go like this. A plus 90 is 180 because angle sum, because they're both A's. So 2A is 180. A is not 2A equal to 90 because you subtract both sides by 90. So therefore A is 45 degrees. So it's 45 degrees each. So label that on the diagram. Okay, we've got 45 degrees. Right, after we do this, in this triangle, all the angles are known, all the sides are known, so therefore we can work out sine, cos, and tan. So we're going to maybe refer to, alright, sit down, the notes are on your table, so we will refer to this angle. So that means this is opposite, this is adjacent, this is hypotenuse. Use that to work out the value of sine 45 and all the other angles. Okay, so sine 45 equal, it's opposite over hypotenuse, so we have to leave it in exact form. So opposite over hypotenuse is 1 over root 2. If you do on a calculator, you get decimal, so you just leave it like that. So if you do 1 over root 2, you get 0.7 something. Okay, so you just leave it in exact form. Remember, we're working out the exact values. Let me write it again. Can you do the other two? Cos 45, tan 45. Alright, cos 45 is adjacent over same thing, 1 over root 2, and tan 45 will be 1 over 1, which is 1. Yep, we got that. Alright, so we've got 3 values so far, and we're going to find more values, 30 and 60 degrees. So we have to consider another triangle. So we're going to consider an equilateral triangle, shown below. In an equilateral triangle, all angles are equal to something, all the angles equal to how many? 180. They add up to 180, but what does each equal to? 60. So 60 degrees. They're all equal to 60 degrees. That will be useful to us. Label all the angles on the triangle below. We did that. Draw a perpendicular line from A to vertex A to BC. So use a ruler. Draw a line, vertical line from A to the bottom. Okay, perpendicular line. Label that as D. So we've got D there. That letter is D. Find the length of BD. Well, because that line is like an axis of symmetry, you must divide BC into 2 equal parts. So that's 1, isn't it? So that's 1. DC is 1. Because it split that the triangle into 2 equal halves. So the BC is 2, so both of these are 1. Maybe we'll put another 1 here, so you know that's 1. Okay, after we find the length of BC, we have DC, or BD, find the length of BD, yes, so I've got it there. Hence, calculate the exact length of AD. So we have to use Pythagoras to find AD. So if you use Pythagoras, AD square equals square root 2 square minus 1 square in exact form will be in surd form, root 3. label that on the diagram as well. So 2 root 3, 1. And then we can find the angle of BAD and then label that angle BAD. Alright, BAD, what will BAD be? 30, that will half. Yeah, so basically that line we just drew split the triangle exactly into 2 equal halves. So that means that will be exactly half of 60, so 30 degrees. So now we've got all the angles in that triangle as well as all the sides of that triangle. And once we have all the sides and angles, we'll now be able to calculate the value of cos 30, sin 30, and tan 30, and also the cos 60, etc. So let's do that. Let's start with the cos 30. So we'll have to label that's the angle here. So that's the hypotenuse, opposite, no, adjacent, opposite, right? So to work out cos 30, you do adjacent over hypotenuse, which is root 3 over 2. So right, root 3 over 2, like that. And sin 30 is opposite over hypotenuse will be 1 over 2. And tan 30 will be opposite over adjacent will be 1 over root 3. Alright, we've got these values. Alright, okay. And then how about cos 60? So you have to change your angle. Also change the sides. So we've got this. Okay, so cos 60 will be, I have to use another color pen. Let's use green. So that will still be hypotenuse. This will be the angle. That will be the adjacent. That will be the opposite, isn't it? So using that, cos 60 is 1 over 2, isn't it? Adjacent over hypotenuse. Sin 60 is root 3 over 2. And finally, tan 60 is root 3 over 1, which is just root 3. Right, so these are the familiar exact values that you learned in year 10. So now we're going to summarize all of this onto the table below. So let's summarize them. So sin 30 is half. Sin 45, 1 on root 2. Sin 60 is root 3 over 2. Oops, didn't come out right. Root 3 over 2. Root 3 over 2, okay? And then we'll do the cos 30. Cos 30 is root 3 over 2. And that's 1 on root 2. That will be half. Like that. And tan 30 is 1 on root 3, 1, and root 3. It's important that if you can memorize this table, that will make a lot of working out much easier. So you should try to memorize this table. One way to memorize it is to write it out many times, and then you should be able to memorize this. So try to memorize. It's very good. And it's on a reference sheet, this triangle, but you have to work out each time using opposite and adjacent. So it is on the formula sheet. So let's scroll down. It's on the first page of your formula sheet. It's right there. So it's given to you, but you got to calculate it each time. So I recommend you to memorize the table instead. So go back. Okay, try to memorize or memorize the above two triangles or the table. But I prefer to memorize the table because it's much quicker. Okay. All right, any question? All good, so memorize this. So we can see some special properties being shown on the table. Let's see what they are. Let's start with this one. Now remember the identity, remember this formula we learned earlier, tan equal to sine over cos. We can see that this is true on this table. Substitute 45 into this formula. What do you get? You get tan 45 equal to sine 45 over sine cos 45. Are they equal? Let's check out what's tan 45. Look at the table, tan 45 is 1. And how about sine 45? 1 over root 2. And cos 45, 1 over root 2. What's 1 over root 2 divided by 1 over root 2? You get 1. So they are the same, isn't it? So this formula works. Not just for 45, also works for 60. Try with 60. And of course, all the other angles. So if I go tan 60 is equal to sine 60 over cos 60. What's tan 60? Root 3. Is it the same as sine 60, which is root 3 over 2 over half? Root 3 over 2 divided by half. How do you divide by half? Times by the reciprocal. And the 2 cancel. You do get root 3, isn't it? So it's consistent with our knowledge about these formulas. This table was just drawn up. All right. We can also see that this formula, the table, also consistent with these formulas you learned before, the complementary formula. Remember, sine theta is cos 90 minus theta. So if I substitute 30, what do you get? You get sine 30 is same as cos 90 minus 30. And what's cos 90 minus 30? 60. Now what's sine 30? Half. What's cos 60? Also half. So they're the same, isn't it? So you can see this formula works. Not just for 30, works for, and then you can see the reversal also work. So cos 30 is the same as sine 60. Yes, it is, because they are both equal to root 3 over 2. Right? So you see some symmetry on the table as well. And the symmetry being displayed on the table is, see half, they are the same. Half, half, root 3 over 2, root 3 over 2. 1 over root 2, 1 over root 2, 1. 1 over root 3, root 3. So you can see that symmetry there. Yep. All right, good. So we're going to use this table to do some questions. So on your next page, please draw the special triangle and then use it or not use it to work out the following. Okay, draw the triangle again. Hopefully you can remember the triangle or just use the formula sheet. Up to you. Okay, see if you remember. There's 2 triangles. There's one with 45 degrees. It's an isosceles, 45. And the other one is this one, the taller one. Like the 60, 30, right? And you got 2, 1, root 3, like that. And use that to help you to do the following table. Or if you remember the values, that will be even better. All right, give you a minute to do so. All right, use that to help you. Actually, I'll go back to the last page just in case you're still copying. All right, good. All right, hopefully you finish. So if you know this off by heart, that will make it easier. You'll be able to do that in under 10 seconds. Sine 30 is half. That's root 3 on 2. You should be able to recognize them and write it down straight away. That will help you a lot. Right? See, I could just look at it and write it down. And it's nothing special. It's all about practice. Okay? So if you can memorize it, it will help you in the long term for the next 2 years. Guaranteed. After that, well, possibly even more. Okay? For the rest of your life. It will be useful. Okay? After we do this, we can do some examples. Okay, so in your textbook, you'll get some examples like this, where you have to add things together. So what you do is, sine 30 is half plus root 3 over 2. They have the same denominator, so you write it as 1 plus root 3 over 2. All right, see if you can do the next two. The next one I didn't explain, forgot. So whenever you square something, you have to write it like this, sine theta all square. They just omit the bracket, so it's like an abbreviation. So when you do that, you have to write sine 60 all square. Note that if you attempt to do that on a calculator, it will give you error. So if you put square there, it doesn't let you, right? So you have to put sine 60, close bracket, then square, like that. All right, so what do you get? What's sine 60? Root 3 over 2. If you square it, you get 3 over 4. Oops. And let's see if it works. So if I do that on a calculator, press equal, you get 3 over 4, which is 0.75. Okay, how about the next one? Hopefully you still remember what cosec is. What's cosec? You would have known it for the exam. Reciprocal of sine, yes. Okay, let's do that. So you have to go reciprocal. What's sine 45? Sine 45 is 1 over root 2. And 1 over root 2 is reciprocal become root 2. Yes? And 6 times root 2 is 6 root 2. Okay, good. Got 2 more problems. Next one's a little bit harder, lots of fractions. So have a try, see what you get. So that's a long one. So I especially gave you a bigger box. Yep. So that's why if you know your exact value off by heart, it makes it easy, isn't it? It will be hard to draw a triangle each time for each of these questions. I mean, you draw it once, but you have to work out each time. It takes too long. Better to memorize it. All right, try the next one. Tan 30 over 1 minus tan squared 30. Have a try. Yep. Useful in later topics. Now we just know why, yeah, it doesn't have a button, but it's good for theoretical purposes that you'll learn later. You can't write, you don't use it when you do SOHCAHTOA stuff, you just use sine, cos, and tan. But cosec is just a new name for a new thing, which is reciprocal. Yeah, it's just a reciprocal of sine. It doesn't have much practical use. Yeah. So it's a special name for reciprocal of sine, right? Well, later on, it's hard to say now. It's later on you will need to use the reciprocal sign. Yes. Yeah. Yeah, not now, but later on. Theoretical purposes. Yeah. Yeah. Oh, okay. Thank you. All right. All right, next one, D. Let's do D. Have you tried D? Hopefully you all had a try. 2 times 1 on root 3 over, have a try, 1 over root 3 all square. Okay, step by step. Now just square the denominator first. So write 2 over root 3. And if you square 1 over root 3 is 1/3, right? 1/3. What's 1 minus 1/3? 2/3. And hopefully your algebraic skills will allow you to simplify this. That's equal to 2 over root 3 divided by, 2 over 3, right? The numerator divided by the denominator. And when you divide, you times by the reciprocal. Yep, like that. And then the 2 get cancelled. You get 3 over root 3. And of course, we need to rationalize. And if you rationalize, you get 3 root 3 over 3. And you can simplify after that, which is just, oh, the pen didn't work out. Good. All right, the 3 get cancelled, so it's a long question. But it's good algebraic skills and surds and skill with surds. Let me write it a bit bigger. All right, good. All right, try the next one if you're ready. Y, obviously. Yeah, have a try. Try to figure out why, okay? All right. SOHCAHTOA, yes, of course use SOHCAHTOA. Yeah, use SOHCAHTOA. Yeah, value of it, yeah. Yeah. All right, finish. All right, let's try to find this. So this is adjacent over hypotenuse. Use cos, so cos 30 equals to y over 8. And to find y, stop talking. 8 times cos 30. And what's cos 30? Root 3 over 2. Now, if you do it on a calculator, it doesn't give you root 3 over 2. It just give you, if you do 8 cos 30, it will give you a decimal. Right? We don't want a decimal, we want exact value. So that becomes 4 root 3 is your exact value. And that's what you need to do in the exercise. Knowing this exact value to calculate this. Any question? Also want to do a bit of next 2 pages, 13 and 14, because on Friday we won't have time to do much work because we have to go through the exam. Today is 3rd, I think it's 7th of April, right? 3rd today, yeah. 3, 4, 3, 6, okay. Alright, let's move on. Okay. Alright, let's move on, thank you. Alright, next page. Alright, we're going to look at a general angle. Again, something you learned last year, let's revise it again. What does sine 30 degree mean? Well, what's sine 30 degree equal to first? What does it equal to? Hopefully remember. Root 3 on 2, no. It's a half. Okay, go home and write it 10 times, you will get better. Alright, sine 30 is half. What does the half tell you? What does it mean? Why, like, give you half, what does it tell you? Ratio of sides between the opposite and hypotenuse, isn't it? So if I draw a triangle, it means that if sine 30 is half, means if I draw a right angle triangle with one angle 30 degree, I will know that one side is 1, one side is 2. But that's not the only triangle you draw. As long as the ratio that the hypotenuse is double the opposite, you work, right? So that just tells you the ratio. So remember, this is a ratio of 2 sides. That's what sine 30 means, and so it does any other trigonometric ratio. That's why we call this topic trigonometric ratio, because they are all ratio. All right? Okay. Now, the next question is, how do I do things like sine? Oh, didn't work. Is that recording? Yeah. Okay. How do I do things like sine 170? We can no longer use the ratio, isn't it? Because it doesn't have a right angle for an obtuse angle. And furthermore, how do I do things like sine 220? It's not inside a triangle. But if you use your calculator, it does give you something. 170 does give you a number. We have to know where that number comes from. And furthermore, if I do 220, it gives you a negative number for no reason. So we're going to decide what it means to do an angle other than more than 90 degrees. Okay? So we're going to have new definitions. But before we do that, we need to define certain things. We have to look at general angles and rays. Okay? So we have 2 different types of angles. Positive angles are measured in anti-clockwise direction, while negative angles are measured in clockwise direction. Okay, so that means the clockwise anti-clockwise is, we'll start from here, that's 0 degrees. Going anti-clockwise, that's 90, that's 180, and then you get 270 up to 360. Okay, right, we got that. So going this way, remember that's the 0. Going this way is anti-clockwise, and which will result in positive angle, positive. And going the other way will result in a negative angle, negative angle. Again, that will be clockwise. Like that. Right, now we define what angles is on a on the 4 quadrants. So this is like your first quadrant. That's your second. That's the third. That's the 4th quadrant. Okay, 4 quadrants. All right, so we got that. Then we're going to draw something on the diagram. We're going to draw 70 degrees, not exactly 70. You don't need a protractor. All you have to do is draw the quadrant. 70 belongs in the first quadrant. You just go 70, finish. That's what you do. Do the rest like the same way. 120 degree will be in the second quadrant. So just go like this, 120 degrees. All right, nothing spectacular. It's very easy. You just have to remember the boundary angle. 0 angles on the boundary, 0, 90, 180, 270. So that will tell you which quadrant the angle belongs to. Well, you go clockwise. All right, well, let's look at this. Let's look at this. Let me see. I do have a, do I have stuff here that I could use? Quadrant. Does it give you stuff? Related folder, pictures, clock. I get clock to explain. Is that interactive? Maybe I'll try with a clock. Now watch this. The quad move things. Let me see if I can move things. You can't move the arms. That's not good. Okay. There's something. Let me see if I could get a dial. Dial. No. How about? All right. Okay. Anyway, I think you know. Let me see. So say I draw something. I draw something. So I move it like yes. Good. All right. So 0 degree, 90. So that's 0, right? So if I 0 to 90 to 180. So what's before 0? Negative. Get it? Yeah, but depends on how you go. So if I go that way, it's positive. Go that way must be negative. Well, in this case, that's our definition. Not fake. I mean, well, that just tells you how to go. So that's negative, that's positive.
Yeah, but how do you do? Because when you go like this, and you have to go that way, when you go that way, it's
I know, but say for example, if someone asks you to turn negative 10 degree, are you going to go all the way 350? That would be too long, right? You just go negative 10. It means you go left 10. Yeah. All right, okay. All right, let's move on. Yeah, a little bit like bearing, but not like bearing. Now, bearing starts from 0. That's 90, 180. It's different from bearing. Not me. Okay, 225. All right, 225 will be over here. Will be like this. That's 225. Okay, just draw this. 280 will be in the 4th quadrant. 280. Now, just keep in mind, a lot of the things we do in the class, in this course, if you ask people on the street, they will have no idea. So don't feel. So you can't just apply real life. Think of it in terms of real life. Yeah. All right. All right, 470. Okay, what's 470 is go 1 revolution, and where would they go? Where would they end up?
Oh my god, spiral. Oh my god.
You end up here, I think. Because if you do 470 minus 360, you still got 110 left, isn't it? Wow. So it ends up here. Ends up here, right? 470. All right.
I hate that so much.
Okay, last one. Negative 150, you go that way. Remember, negative. Oh no, the pen's no good. I need to get a better laptop that comes with the pen. No, I want the school to get me one. They never got one. All right. No. Same thing. Okay, actually negative 150. Yeah. All right. But there's no better alternative. Oh, I mean this one, this thing. What for later stuff? For the next stuff we're going to do. You learn that next lesson. Say again. For part E. For part E. Yeah, 110. Yeah. So you know what that means? Means that you go one revolution and 110 extra. You end up in the second quadrant. Yeah. Because you went over 360. Because the question is like people will ask in maths, people who study maths, if there's 360, there must be an angle beyond 360, and that's how we define it. It doesn't stop at 360. Well, you just turn more. You just turn more than 360. Yeah. It's like saying there's $100, but how can people have $200? Was it the same thing? All right. Yeah. Yeah.
I jumped up 700.
You can't apply in this context. All right. Let's not argue about this because just look at the definition, okay? All right. Okay. Okay. Yes. But we have been using this language since long time ago, so we're not going to change it. Yeah. All right. Okay. Let's continue. One more thing. We need to know about related angle. What's a related angle? It's the acute angle the ray makes with the x-axis. That's an important statement because we're going to use it later on. Related angle. Okay, now let's calculate the related angle for each of these. Remember, it is the acute angle the ray makes with the x-axis. So for the first one, the related angle is the angle itself. So you just write related angle, RA for related angle, or maybe we'll call it theta for related angle. Theta is 70 degrees. That's your related. Now for the second one, the related angle will be, again, the angle you make with the x-axis will be this one. That's your related angle. All right, and what's this angle? 60, yes, well done. So you just subtract from 180. Now the related angle for the third quadrant is this angle. Okay, remember, it's the acute angle the ray makes with the x-axis. Okay, x-axis. So in that case, it will be 45 degrees. If you wonder how I did that, you just go 225 minus 180 will be 45 degrees. So that angle is the related angle. And the other one is 180 minus 120. You get to 60. Is the next topic in the next exam. Okay, next one. This angle here, you just go 360 minus 280. That will be 80 degrees. 80. That's your related. And this one, you just use the 110. So you do 180 minus 110. That will be 70. Remember, it's the acute angle mixed with the x-axis. Acute angle. Yeah. And this one, you just go 180 minus 150. You get 30 degrees. It's always positive. Always positive. But the angle is negative, yep. But the related angle is always positive. So the related angle is always between 0 and 90 degrees. Okay? Regardless whether the angle is negative or positive. Yep. I think that's all we did. Okay, good. Okay, we'll do one more section, then we're done. Okay? All right. Next page. Angles of any magnitude. Now we're going to understand how to do this now. I'm going to explain to you how to do this. Y is a negative 0.64, etc. So, angles of any magnitude. So what we do is we first draw a ray like before. Maybe do it in red. Or in blue. Okay, red. Draw a ray like this. That's the angle. And this line, ray, crosses the circle at a point x, comma, y. Now we're going to define sine theta, cos theta as follows. Sine theta is equal to this number here, y value. The cos of the angle is equal to the x value. And the tan of the angle is y over x. That's our new definition of sine, cos, and tan. And how is that related to our old definition? Let's look at the diagram more carefully. All right. So when you draw a ray like this, you can get a right angle triangle. Right? So you see there's a right angle triangle there. There's a right angle triangle. On this right angle triangle, you will have three sides. What's the length of the hypotenuse? It's a circle, so the hypotenuse is radius, which is 1. And the length of the other two sides are x and y, isn't it? So if I use our old definition, SOHCAHTOA, we can see that sine is opposite over hypotenuse. And if we do opposite over hypotenuse on this triangle, it's 1 over y. Y over 1, which is just y, isn't it? That's why we'll call sine theta y. And then how about cos theta? X over 1, adjacent over hypotenuse, which is x. And tan is opposite over adjacent, which is y over x. Right? Opposite over adjacent. So that's how we come with this new definition. Now, why is this new definition more useful than the previous one? Because it can go beyond 90 degrees. Okay? Because it can go beyond this line. So if I draw a ray there, say if I draw a different ray, if I draw it here and measure the angle, I could work out the x and y value. Right? And if I know the x and y, I work out what sine and cos is, and tan. Okay, so that's why we have a new definition, because on a circle, I could draw a ray anywhere, right? Anywhere I draw a ray, I get x and y. If I get x and y, I could get sine and cos and tan. Okay, we're going to use this definition to work out some ratios. So we're going to do an example. You don't need to draw a triangle. That's why there's no it's no longer a triangle now. You just say coordinates. So if I draw 180, what's that point? What's the corner of that point? So that's 180. Yeah, what's the corner of that point? Will be negative 1, 0, right? So what's sine 180?
Oh, right.
What's sine 180? It's y, isn't it? 0. Does it give you 0? Let's check. Sine 180 is the y value. It does give me 0. Have a guess, what will cos 180 equal to? It's the x value, isn't it? So if I go to the calculator to cos 180, what do you think they should tell you? What should it tell you? Well, it should be the x value, negative 1. Right, so let's check. Equal negative 1. Yep. All right, so let's look at this diagram. So to work out these values, you need to work out the coordinates. Let's work out the coordinates. So if you count the grid, what's the corner of this point? So you count, so each grid is 0.1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we 0.9 and then 0.5, right? So that's your X, that's your Y. And how about the next one? That's 120 degrees. So what's this coordinate? Well, it's going to be negative 0.5, comma 0.9. So if you do cos 120, what would it be? It's going to equal to X, isn't it? What's the X value? Negative 0.5. And sine 120 is Y value. What's the Y value? 0.9. Let's check whether it works. So we can use your calculator and press cos 120. Cos 120. You get negative 0.5 as expected. And if I do sine 120, I should get 0.9, correct to 1 decimal place. Alright, get the ideas? And then tan 120 is Y over X. And what's Y? Y is 0.9 over 0.5, which is about 1.8. Is that right? So just do that. One of them is negative. That's negative, so it'll be negative 1.8. Does it work? Tan 120. Yep. It's a little bit off because of the rounding error. Try the next two. Try this one. Work out the coordinates. See what you get. 315. Not until Friday. That's why you get a result on Friday. So you get the whole week to practice and think about this. Alright. 315. So what's the corner of that point? So it will be 0.7, comma, negative 0.7. Negative 0.7. Okay, good. Right, so cos, what's cos again? It's X. X is 0.7. What's sine again? Y. What's Y? Negative 0.7. And how about tan? Y over X, which is 0.7 over negative 0.7, you get negative 1. Okay? You can check on a calculator. Tan 173.15, you get negative 1. Okay? So that's how the calculator calculates it based on this circle, a unit circle, by finding out the X and the Y coordinate. Alright, okay, any question? Yep, alright, we're going to go through more. Okay, one more thing. Shh. Okay, let's look at the quadrant. First quadrant, second, third, fourth. Okay, put the angles 0, 90, 180, 270, and 360. In the first quadrant, all the coordinates are positive, so both X and Y are positive. How about the second coordinate? The first x value is negative, y value positive. Is that agreeable? And the third quadrant, both x and y value are negative, right? And this one, it's going to be positive. Because anti-clockwise will go anti-clockwise. All positive angles are measured anti-clockwise. That's why I go around this way, rather than the other way. It's anti-clockwise. Okay, now remember what sine theta equal to? What's sine theta equal to? Y. What's cos theta equal to? X. What's tan equal to? Y over x. So in the first quadrant, is sine positive or negative? It's positive because y is positive. And cos is a positive or negative? Positive because the x is positive. And if you do tan y over x, so you do positive divided by positive, what do you get? You get positive. So in this quadrant, everything is positive. All. Okay. Now in the second quadrant, again, sine theta is y. Is sine positive or negative? Positive, because y is positive. Cos is because x is negative. And if you do tan positive divided by negative, you get negative, right? So therefore, which one's positive? Only sine is positive. And then the next one, third quadrant, sine is negative because y is negative. It's negative here. And then cos is negative because x is negative. And positive, negative divided by negative is positive. So only tan is positive. Yeah. And the last quadrant, fourth quadrant, sine is negative, cos is positive. Negative divided by positive is negative. Only cos is positive. So how do I remember this order? You just go ASTC. And the way to remember this, you say all stations to central. So in the below where it says mnemonic, write all stations to central. That will allow you to remember which one is positive, which one's negative. I think that's all. Okay, we'll continue with that tomorrow. Not tomorrow, next lesson. Okay, all right. So start the exercise today, 6.6.